Hello everyone, I trust you're all as well as can be. Welcome to Frontline Systems webinar on optimization using the power of Analytic Solver plus RASON. My name is Dr. Sima Maliki and I'm happy to present this webinar. I have a little cold, so my voice is not ideal. I'll apologize for that in advance. In this virtual gathering today, we are going to briefly talk about and share some of the possibilities that Frontline System software offers to build and test your optimization models, and then deploy and manage your models as cloud services. This presentation should roughly take about sometime 45 minutes and sometime with some additional examples almost to 50 minutes. Okay, so and then we will have time at the end for you to ask your questions. I can also unmute you at the end of the webinar. If you have any questions during the webinar, please feel free to type them in the question box, and I will also try to look at them during the webinar. So if it is something during the presentation that I can address for you, I will try to do that. I enclose Analytic Solver plus RASON product brief. This is a document written by our president, Daniel Filestra. It is a very well summary, high level that's very helpful to understand the power of Analytic Solver and another product of Frontline system, RASON. Okay, once you develop and test analytic models, Excel is just usually the first in Excel. This is usually just the first step. So to gain the real business value, you also want to get the results of your models to the hands of people who need to use those results, and doing so in an ongoing basis. People in operations, sales, customer service, manufacturing. This has to be in a form that they can easily ensure it is up to date, rerun the optimization model, for example, and view the results or plug them into another software or application or another process. So we call this model deployment. And today we will talk about RASON, which is our cloud platform for model deployment. So in the beginning, we are going to start with talking about mathematical optimization, a tool you can use to allocate scarce resources to the best use. And again, I'm sure a lot of you are familiar, I have used optimization, but this webinar attends a mix of people who are new to our products and people who are using our products. So I try to be not very basic, but these resources could be money, people, space, warehouse, capacity of pipeline, and I try to show a few examples today. Okay, and I'm going to spend some time looking at a few examples, looking at some of the capabilities that Frontline software offers in Excel. After that, we will spend some time talking about how to deploy the models and how make them available to other people if you want to do that. And it's very easy. It's just as simple as clicking. Okay, and I'm going to show you that today. And as time allows, we're going to how to make models available in other applications such as Microsoft Teams, Power BI, Tableau, or your desktop or server application. This is just a summary slide with two screenshots. On the left-hand side, you can see Analytic Solver, and on the right-hand side, this is a screenshot of RASON, our deployment platform. I just want to show you a few things that this is a window into RASON. Okay, so Analytic Solver and RASON, which is our deployment platform, are very well integrated. So today we will learn to work with both of these products after going through Analytic Solver in Excel, and the same applies to the Analytic Solver cloud base. And make sure you know that once you have a license for Analytic Solver, you can use the desktop and also the cloud-based version with just one license. So, and I just want to clarify what is this. Okay, so in Excel, imagine you want to build an optimization model and you want to feed the results of optimization model into a simulation or into a data mining or vice versa. Okay, you have to do a lot of programming to make this possible in Excel, a lot of VBA. But now with RASON, this is very simple as dragging and dropping icons. So imagine this one is the first step, an optimization model. And I'm using 3 of the results, feeding them into a second model. So we will talk about creating and running decision flows that are very easy to make in RASON platform. And this would be toward the end of the webinar, okay? Now it's time, let's switch to Excel, open our examples. I'm going to spend a few minutes going through the ribbon, build a very quick, simple optimization model, talk about some of the advanced tools that are available to an analytic solver, and then we go forward from there. This is a very simple transportation problem we're going to build together, but just before that, let's quickly walk through ribbon and see what is new. So on the top, let's start from the top left, model tab. If you click on model tab, you always get this question, how can I get rid of the task pane on the right side? So let's clarify. This is task pane in the right side. And if you look at the user guides, it says task pane and use this option. So this is task pane. So clicking on the model tab displays or hides the task pane. The model dropdown offers you additional options for multidimensional modeling. Today, I can't fit an example of multidimensional modeling, but if it's something that you're interested in and the user guide doesn't help you to really get a grasp of it, email us and we are happy to create a webinar or discuss, have a meeting and invite you all to discuss more about focus on multidimensional modeling. Okay, so this allows you to summarize a very large model into just very small dimensions and works very great with Power Pivot and all the other Excel functionalities. Next group, simulation model group. I am sure all of you know that Analytic Solver is a tool that not only gives you the capability to perform optimization, deterministic optimization, but it also allows you to run risk analysis, allows you to build Monte Carlo simulation models, and allows you to run and solve stochastic optimization problems. So this is the simulation model group. We have a webinar next week. Join us if you want to learn more about the simulation capabilities, but let's just quickly click on distributions. And these are the more than 50 distributions. Next week, we'll talk more about that. And I want to show you in the custom distribution, we feature the famous category of MATLAB distributions. We'll talk more about that next week, but this is on as of now, to the best of my knowledge, we are the only commercial product that make MATLAB distribution available, and MATLAB distributions can fit any historical data much better than any regular analytical distribution, but we will feature that and talk more about that next week. Okay, you can induce correlations, use results to calculate various statistics, measures, and much more. Next is optimization model group, decisions, constraints, and objectives. So we will come back to this once we want to define the optimization model. Next group is decision model group. So as you can see, this is the group of icons supporting DMN, business rules, and decision tables, following the DMN standard, decision trees, and the box function. Okay, DMN box function. These are all summarized here for you for easier access. And let's look on the next group is parameters. So you are fully capable of building parametric optimization and simulation models. Okay, so as time allows, I can show you one, but it's very easy to work. And instead of running one optimization with the input parameter, changing it and then rerunning the optimization, you can just define optimization parameter from A to B, an interval or a specific values, and run, for example, 10, 20, or 50 optimization for each of those values that you are interested in. Next, simulate. This allows you to run interactive simulation and much more. We'll talk about that next week. And then optimization. You can solve your optimization model in different steps. Here is our deploy model option that we will spend some time in the last section of the webinar. This is all you need to deploy your models and make the results and share them with other people. So here your optimization or simulation model can be deployed to teams. They can be deployed as cloud services. You can make them deploy to run on Power BI, Tableau, your application, and then create a web page. So we will come back, we'll talk about all of these options as time allows. Then you have different reports and charts available for optimization. You have quite an amount of reports. I'll try to feature one of the reports that is very helpful. So we'll talk about that today. Different charts for optimization and simulation. If you run multiple parameters optimization, you can get multiple optimization chart. And then tools allows you to use fit options. We'll feature fit in the next week webinar. This is fitting an analytical distribution to your historical data, and I will also show you how to work with MATLAB family of distribution. Get data allows you to bring data into Excel from different sources, different worksheet databases such as Microsoft Access, SQL Server, Oracle, Power Pivot. You can work with file folder. This is for data mining purpose. You can, for example, bring text file, get a sample of text file. These are all allow you to get a statistically representative sample of data. So file folder is available, and you might know that in data mining we feature text mining. So text mining is available to you. And the last one is connecting to our Apache Spark Big Data Cluster. This allows you to work with big data. Lots of options on the ribbon for optimization and simulation. Let's just keep it at that. These options are all available in the task pane, also for license status and help. So from help, you can access user guides, example models of the examples I'll be showing today. You can also access Solver Academy. I think the good news is in near future, Solver Academy can be available when you purchase a license for a certain time period. You will have accessibility to use Solver Academy at no additional charge. But that's something to ask for when you talk with customer support or the sales team. Okay, I didn't say that. Okay, let's look to the right. This is the task pane. In the model tab, you can get a summary of model. For example, if you have an optimization model, this part allows you to see a summary of each component of your optimization model, variables, constraints, objective, and allows you to manage them. Okay, so as we build this optimization model, you will see how I can work with this part. Platform are options for optimization, simulation, and some advanced options. As time allows, I can show you more. If you scroll down, there are generalized options down here, like for example, setting bounds on your variables. You can do that here. Some advanced options and general that apply to all the models, all optimization and simulation models. Engine tab. So we have 5 built-in Analytic Solver and also additional optional engines. The standard engine are the built-ins. I think now if you install Analytic Solver, you see all of them, and you can run limited time the advanced engines, the optional ones. But the standard ones cover based on the structure of your optimization model. You can use a GRG nonlinear to solve nonlinear type problems, LP and quadratic engine, standard quadratic, evolutionary for solving non-smooth problems, interval grow bar that uses interval methods for deterministic global optimization, and much more. We also have additional plugin engines. These are commercial products, for example, Groby, Nitro, OptQuest, Express. These are powerful, high performance. Groby is for linear, for example, it can solve linear, quadratic, and then Nitro can solve smooth nonlinear type optimization problems. Any questions so far? Okay, and the next one is output that gives you a summary. And there is a workflow tab that this is mainly relevant to data mining. So we'll feature this part in data mining. And then tools tab, let's cover tools tab. If you run multiple parameter simulation and optimization, for example, you run 100 optimizations, you can cycle through individual optimization using this optimization button. And then freeze and unfreeze is helpful when you're sharing your, for example, simulation model with one of your colleagues that they don't have Analytic Solver installed. So some of the function may return error or NA. So you can actually freeze the function so they can see all the values. And then when you get the workbook back, you can unfreeze the side functions. Okay, this was just a quick review of Analytic Solver. Now it's time, let's quickly build this optimization model together. Meanwhile, if you have any questions, please feel free to type them in the chat box. If you want me to talk more about the feature, definitely let me know. So we are going to build this simple transportation optimization problem. Let's practice and build it together. So let me go back to slide. We are talking about 2 factories, a company with 2 factories that wants to minimize cost of shipping to 5 different customers. Each factory has a limited supply. Each customer has a certain demand. Our goal is to find the best shipment plan to meet the demand in the most cost-effective way given the supply available. So We want to, what do we need to do to use optimization and get the best result? We have to build a model that goes from business situation in quantitative terms to a model that we can solve using Analytic Solver. To achieve this, you need to determine your decision variables, your constraints, and your objective. I put this slide for you because it summarizes how you can quickly come up and answer these questions to come up with your decision variables, objective, and constraint. To find out what are my decision variables, I always ask what factors are under our control. So in our transportation optimization problem, what is the factor that is under our control? How much product to ship along each route? Objective, what measure are we trying to optimize? We want to minimize total cost of shipping. And what are the restrictions? For example, amount of product available in each factory, and then the amount of customer needs, the demand. Those are different constraints. Okay, what restrictions limit our choice of decision variables? Okay, so let's go back to Excel. Let's make sure you can see my screen. Okay. So these are shipping costs from factories to customers, constants, input to the problem. Here it's factory capacity, and here are customer demands. For each possible route between a factory and customer, I need to reserve one decision variable. Very straightforward. I'm going to put some zeros here to make it more clear. How do I define this block as my decision variables? Select the block. You can do it one by one or just select the whole block. Go to the ribbon. Okay. There is a shortcut. I'm going to show you both ways. Okay, so you can just click on Decisions tab on the ribbon. And now under Optimization, you can see that. Let me show you here. C16 through G17 are added as group of decision variables. So you can just click on Decisions, or you can go to Decisions and then choose Normal. And then if you go to Optimization, you can say I added it twice. So let's right click and delete one of them. Okay, so very simple, defining our decision variables for this transportation optimization problem. Now, let's talk about the objective. What is our goal here? Minimize total shipping costs, right? From factories to customer. So we need to provide the service with minimum cost, right? So objective is minimization of total cost of shipment. Obviously, I have to calculate total cost of shipment along all the possible routes, right? So let's define the objective together. What function can I use? I have to multiply each shipping cost on each route by the amount of product that will be shipped. A very good summary function to use is sum product. So let's click enter, equals sum product. Select an empty cell, type in your function, and then you can array enter the shipping cost, first block, comma, decision variables. Close this, hit enter. So this way, I calculate my total shipping cost. Now I have to tell Analytic Solver where this function is and what do I want to do with it, right? So select the cell. Again, you can just click on objective and choose min to minimize this. Okay. Okay. G21 to be minimized. You can see it's added. Another way, let me show you the other way. Select it. Go to objective, minimization. We have normal, expected, and chance. Remember, we talked about Analytic Solver. It's just much more than just doing deterministic optimization. It allows you to perform stochastic optimization models. So we have expected, chance. So we can choose normal. Okay, so G21 to be minimized. Next, what are our constraints? So I have to make sure my capacity doesn't go beyond 60,000 for each factory and I meet customer demand. Very straightforward. So let's calculate the totals that are going out of each factory, sum of all the cells. And then I can drag and drop this function for factory do. Okay, now you can select this whole block, go to constraints. Gonna use this quick way. It should be less than or equal to, and on the right hand side, so this is a add constraint dialog box. So you can see on the left hand side I have H16 and H17 because I selected them in the beginning, and then on the right hand side I have to click on this button and add these two cells. So let's click here, add the range. I16, I17. If I have two cells on the left, two cells should be on the right. You can change the sign here and click on OK. And you can see now we have the constraint added under normal constraints. H16 to H17 less than I16 to I17. Now let's do similar for customer demand constraints. So let's calculate how much is shipped to each customer from both factories. Drag and drop the formula. Select the block. This time I show you the other way constraints. Normal constraints, it should be greater than or equal, right? That can totally work. And then here it could be the demand, the value for demand, and click OK. Now, sometimes, especially when it's minimization, it is helpful to tell Analytic Solver that decision variables need to take positive values. There are multiple ways to do this. Select the block of your decision variables, go to constraint. This is a bound on the decision variable, so you can actually go to the third category, the variable type bound, and it should be greater than or equal to 0, right? Since this is such a common practice that we want the variables to take positive values, under each engine there are additional general options. So one of them is assume non-negative. You can change it from false to true, and it does exactly the same thing. Okay, we have defined this optimization problem using the modeling logic for Analytic Solver, okay? And we didn't pay much attention to the structure of this optimization model. One more very important part is, what is my model structure? Is the linear programming model? It is non-linear. So let's go ahead and click the solve button or optimize button. And we are going to use a capability of Analytic Solver, a feature called guided mode. And let's see how guided mode can help us, okay? So at this point, I define my model. I don't know what is the structure. I mean, I kind of know because every function was linear function of decision variables. Remember, the objective, total shipping cost was a sum product, a linear function, and we only had some functions for the constraint. So pretty quickly you can come up with the idea, okay, this is a linear optimization model. But if you don't pay attention to that, that is also fine. Let's click on optimize button on the ribbon. So just click on the light bulb. This is called guided mode, okay? Guided mode is a step-by-step help that can give you information about your modeling efforts, okay? And it gives you a lot of help, okay? So this is going to help you understand your model, choose the right engine, identify and fix problems, and get best answers, okay? So let's see how this is going to happen. So I'm going to click on continue. The first part is the analysis results. It is telling us that good news, your model was diagnosed as linear programming convex, okay? Now, based on the structure we have to choose the right engine to solve this kind of problem, okay? I didn't pay attention to my engine choice, but this guided mode is actually verifying that my choice is not recommended because this is a simple linear programming convex model. We don't need to go to the effort of using a GRG nonlinear to solve this problem, okay? So here it is giving me all the other choices that can be used because I have all the engines installed, right? So let's click on standard LP quadratic engine and click on next step. And finally, it is telling me that all the constraints and optimality conditions are satisfied, and especially we expect that with a convex linear programming model, right? And it also gives some information. Since the model is linear or convex, the solver has found a globally optimal solution. There are no other solutions satisfying the constraint that has a better value in the objective. Okay, so we can be assured that this is the best optimal solution for this optimization problem with current assumptions. So let's click OK. Now we can see the shipment plan to minimize our total shipping cost, 192,750, and then these are how the products are going to be shipped between factories to meet customer demands. Okay. Once you solve the optimization problem, you get a summary report in the output section. It tells you how much time was used, what engine was used, and then there is a hyperlink. You can always click on that to learn more to what it means. It brings Analytic Solver online help. Especially, it's very helpful when this message is not green and it is, for example, red. So this would be very helpful, quick guide to see why I'm getting error or there is a problem. Okay. So Solver found the solution for us. Total shipping cost 192,750. Very simple linear programming convex optimization model. Now, there are more elaborate versions of this transportation optimization problem available. So this is another version of it, okay? I think this is the main one. So here we also have warehouses. So there are another hub added to the problem, from factories to warehouses to customers. Okay, so you can see we are increasing the complexity of problem. So for example, we have factories, warehouses, and customers. So if you were to, for example, use simplex to do this, you have to define I, for example, I index for factories, J for warehouses, and T, for example, for customers, right? So you can see the dimension is kind of changing, and this gives you a very good idea to how to work with more advanced type optimization problems. Now let's make it even more complicated. Let's go to transport 3, and you can see here we also have different type of products. Same problem, but we are elaborating the complexity of problem. Now we have different type of problems, so different kind of products for each factory. Okay, and I think in the last one we're also deciding about production costs and how much to produce in each of the factories. So we are even adding like a decision about, well, what is the best shipment plan to meet the demand, but also, okay, based on that, how much should I produce in each factory? So we actually, in all the other transportation, the amount to produce in each factory was a fixed information that was a parameter to the optimization model, right? But this one actually make that also a part of our decision-making process for the optimization problem. So if you're interested, I'm happy to send this transportation optimization models to you. And this is not only useful for transportation, any other optimization model can be looked at the same way. So it's very helpful for you to click on help if you're starting to build your optimization models, and click on example models and go to optimization examples. And you can see we have as from simple as product mix to blending type problem, process problems, cutting stock. We are also showing some example with VBA, refinery operations. A lot of our products are used by refinery and oil and gas industry, energy industry, working capital management, financial industries, and much more. You can scroll down. There's a stock portfolio, bond portfolio, and much more. Okay, so these examples are available, and you can explore them if you want to learn more about our products. Okay. And some examples about Power BI and also dimensional model. Okay, next, let's go to another example I want to show you. This is the goal is for this model, I don't want to spend time about telling you what type of optimization is an inventory type planning model. A lot of time this happens that our customers contact us that I am not able to get a proven global optimal solution, and once we look, the model is non-smooth. Some of these non-smooth optimization problems is just because, for example, you use if function or what if function or VLOOKUP. A lot of them can be fixed and prevented. This problem, let me show you. This is again, inventory type problem. I'm happy to send it to you. Once I get a model, personally, always I go to, let me show you this option. I want to understand what is going on. For example, if any of you send a model to me and I want to review and find what's going on, this go to webinar is blocking me. Let me move it a little bit more. Sorry about that. Okay. On the task pane, you can see there are two options on the right side. The green arrow is just like the optimize button on the ribbon, but next to it is it's called analyze without solve. Okay, so let me see. Let's go back to, let me change to arrow again. Okay, now I can click on this button. I'm going to use guided mode again. This time I'm just analyzing this optimization model, and I want to learn more about what is the structure. Okay, and let's click on continue. Okay, analysis result, your model is non-smooth model. What is a non-smooth? Why do we want to avoid non-smooth model? Because very difficult to solve. It can take longer to solve other than other model types, and answer may not be globally optimal. So you might just get a feasible solution. So the ideal way is just trying to avoid getting to non-smooth type problem, especially when it's possible to keep the model linear or a smooth nonlinear convex nonlinear problem. Okay, now let's look at the what to do. This section tells you that you can stop solving, choose report, structure report, and find out what is causing the model to be non-smooth. So let's do that. Okay, I wanted to show you. So I'm going to stop solving and then go to reports, optimization, and you can see the structure report is now available to us. Okay, it diagnoses model type and tells us where the problem is causing the model to be non-smooth. This is a small optimization problem, but imagine this is a very large optimization problem with hundreds of thousands of decision variable and constraints. So then this structure report becomes really valuable. Okay, but I just want to show you a use case. So let's click on that. Now here is the report. It is telling me that there are 9 variables and dependencies, all the functions, and it tells me what is the objective cell in B19, and this is causing the problem. Okay, all the problems are B19. So let's click on B19. Here's the objective, right? I clicked on it. It's a it just brings me to B19, and you can see that this is objective calculating the, I think, cost of inventory something. And then if you look, it has some comes to this periods, different periods, and let's look at that. There are some sum functions, okay? And then if you look, these are if functions. So that is what causing this problem to be non-smooth. Why is that? So once we are exploring different values of B10, so let's see what is B10, okay? One way of doing this is from formula. Okay, let's select that. Type precedence, P10. Okay, so that's the easy way to do it. P10 is a decision variable. So in the period 1, I am using an if function that the logical part depends on the decision variable B10. So if B10 is greater than 0, 1, if not, get a 0 value. So you can imagine once we are solving this optimization problem, the whole feasible region changes according to different value of this streamer. It just jumps, right? It creates discontinuation. So that's what causing a problem to be non-smooth. If the if function or the VLOOKUP, the logical part depends on your decision variable that changes during the process of solving optimization problem, then that will change your model structure. Okay, so if you have if functions that are inputs and you're just doing some inputting some data, and then when it's used in the optimization, they're constant and they don't change during the process of solving optimization, that is fine. But when the logical part actually depends on the decision variable, you can imagine how it changes everything. Okay, so now we have a problem. Now how can we address this? Let me go to formula. Okay, escape. How do I remove arrows? Okay, so we have a non-smooth type optimization problem. Let's go back to Analytic Solver. I want to click on optimize and see what guided mode can tell us. So one way is to just go ahead and solve this problem with the evolutionary engine. Let me show you. Go to engine tab. If it cannot be linearized, you can use evolutionary engine. Okay, and a standard evolutionary engine. Okay, here it is. It features genetic algorithm and taboo search and scarce search. Okay, all these are featured. And let's go back. Let's use guided mode, because Analytic Solver actually has a capability to transform non-smooth optimization models for you. Sometimes it can do that. Okay, so let's click on optimize, guided mode, click on continue. It is telling me the model is non-smooth, as we know. Click on next step. Now it actually able to automatically transform this model from a non-smooth structure to a linear mixed integer LP MIP type for us. Okay, so it introduces some integer decision variables to transform the structure for you to a linear format. So let's click on next step, and now it is solving a LP MIP for you, and here is the optimal solution. We solve it as a linear type of problem. Okay, I have a summary of techniques to linearize functions using binary integer variables. So if you're interested, and this is something you might be interested in, for example, I talk about here how to linearize ratio type constraint instead of, because this easily can change the structure problem, okay? Because there is a decision variable here, okay, in the denominator. Or let me show you other example. This talks about how to linearize them, or building integer programming models. For example, use of integer programming, for example, let's see, different like relationship among variables, or it shows about fixed charge examples, okay, how to linearize those kind of objective threshold levels, okay. A decision variable is greater than 0 or greater than a specified minimum, or a semi-continuous variable, how to linearize that. Or now it talks about the second half of the presentation, talks about how to function like non-smooth transformation. We just saw that Analytic Solver guided mode showed us that we sometimes it automatically transforms the non-smooth for you, and we saw an example of that. But it's really good to know and actually avoid these non-smooth functions. So min, max, ABS, choose, lookup, okay. For example, if you have an if function, if j is greater than 500, use L5, it's other for M5. I show you here how to linearize that, okay? Replace that with some additional binary variables to make it linear. So if you're interested, I'm happy to share that with you, okay? So let's go back. And again, Analytic Solver has the capability to help you, but if you want to go ahead, if you're in the designing stage of your model, you can actually do that yourself. And if you go back to the model tab now, you can see that initially the decision variables are around 9, right? But let's look here down here. I want to show you that now the number of decision variables are increased. Okay, it's increased to 27. And also you can see the model type is LP MIP, okay? Okay, excellent. I showed that. Let's go back to transportation optimization model. Okay. Any questions so far regarding modeling and regarding using some of the advanced capabilities of Analytic Solver? Okay. Now we have built an optimization model together, the transportation optimization. What can we do to share these results with other people? Okay, let me quickly show you on a slide. If you want to have a mobile application, web application, work with Power BI and Power Apps, you need to have a backend server, okay, that you can send requests and get the results back. For example, the server can also solve the model, okay? So the whole idea of what we are doing from this part is how we can make it very easy for you to create your web application, mobile application, use your optimization models and make it available, make the results available to other people, model deployment, okay? So we are offering this server for you. I want to first show you the full image. The slide I made to make it very visually clear. We are going to start from an Excel model that we have created in Excel. Now, our end goal is to, for example, have a web application. So to have a web application, I need to have a backend server, right, to send requests and everything. And then if it's optimization, to solve it for me. So what is going to happen is RASON will do that for you. Okay, so we have a RASON server. We are offering that to you. It's an Azure-hosted platform that allows you to create cloud services from your optimization model. So if I'm starting from Excel, I can click on cloud service and promote my model in 2 different formats. I will promote it to run on RASON cloud server, okay, and be available to any other clients or applications, okay? Sorry about that. Okay, I hope this makes sense. So how do we do this? Let's go back to Excel. Oh, before that, let me show you RASON. Okay, this is rason.com. Okay, so we are looking at RASON through a front-end portal, which is rason.com. Once you promote your models to run on the backend server or RASON cloud services, It would be nice to be able to make changes, maintain the model, or create those decision flows that I showed you in the beginning, that you can, for example, use this optimization to fit into a simulation and much more. This is just the briefly tip of the iceberg that I want to show you what is available. So RASON stands for RESTful Analytic Solver Object Notation. It's a modeling language embedded in JSON, JavaScript object notation, and a REST API. And this makes it very easy for you to create and test and deploy decision services. Okay, I don't want to go to a lot of details, but let's get to action, actually use this. Okay, so let's bring our Excel workbook. I want to promote my Excel model to run on RASON service. Let's click on Analytic Solver Deploy option group. Okay, so on the top you have deployment wizard. If you are not sure what options to use, you can always click on deployment wizard and click on next, and it gives you information for each possible options that are implemented on the deploy model group for you. Okay, you can use, if you are new to RASON, give me a quick test. I want to share model results in Teams. Okay, I want to run my model as a cloud service that web and mobile application can easily use. Okay, so you can come through deployment wizard and go step by step and learn more about each one. Of course, there is a user guide also available in these webinars, but we also made this available for you. Okay, let's go back to deployment model. We will come back to manage models. So I'm going to skip Teams. You can go step by step, try that to share your model results available in Teams. Let's go to cloud service. So there are two ways to do this. One is RASON model, one is Excel model. It's very simple. Excel model, just post the Excel workbook itself to RASON server. Okay, just click on that. You have to give model a name, transportation optimization. Let's put today's date 6/8/22 and click on save. Please note that you can actually have the workbook reside on OneDrive, so just give a name to your model and click save. A few things will happen. RASON.com would automatically open up, and then it will show us a copy of the model that is already sitting on RASON cloud service. Okay, we created a cloud service from our optimization model. We promoted the Excel model itself to run on RASON server as Excel workbook itself. It is at that advanced, so you don't need to translate the model. Okay, so here's the Excel workbook. Okay, now let me give you a tour of what is happening. Remember this slide? Let's go to next one. Okay, here. I clicked on deploy model cloud service. So far, we just used the Excel version itself. So my model is now sitting on RASON server, but I want to be able to run some tests and manage the model, make some changes. And all of this is possible through the front end portal called RASON.com, okay, that automatically opened up for us. So I want you to differentiate that there is a RASON.com, okay, which is a front end portal. Itself, it is an application, a web application that works in the backend with RASON.net, which exposes a REST API and allows any other application to perform optimization, analyze and solve optimization model, fit a train model, invoke a train model to score new data, and much more. Okay, so front-end portal RASON.com. In the backend, there is RASON server that can solve the optimization and give us the result back. Okay, so let's go back. Now we know where we are. We are in RASON.com, the front-end portal. So the model is already posted to RASON server. Down here, you can see how this communication with RASON server is happening, because it's a REST API. We are using GET, HTTPS, and much more. I mean, I'm not going to go to all these details, but you can see everything is being done automatically for you. On the left-hand side, these are all the models I have that are sitting under my account on RASON server. Each model that you're working with, you can see the properties on the right-hand side. So it's pretty simple. The model part is here, properties are on the right. On the left is all the models I have. And on the top, you have some model execution options, okay? So for example, if you want to solve this optimization model on RASON server and get the results back, let's click on solve optimize, okay? Because it's optimization, I can just click on optimize. So I give this request to the RASON server, the model will be solved and it will be loaded, then immediately will be solved and the results will be available in RASON for us, okay? As soon as the results are available, parsing, diagnosis, solving, and then you can see the results will be posted here. These results are available in JSON syntax, okay? Remember, RASON works with JSON syntax, right? And you can see that these are the final variable values, very familiar, right? The transportation optimization, and this is final objective, okay? Now, the results from RASON server can be available in two formats, OData and JSON. Okay, so you saw how to get the JSON. If you use the solve button, okay, solve button, let's do that. And I want to show you that actually both ways you can use that. Here are the results. So now we can see the results in OData format, okay? Just these are the final variable values. You can see the objective, and the beauty is you can actually switch. Clicking on this part, you can switch between JSON and OData. Okay, here are the results in JSON, or you can switch back to OData format, okay? Now, let's go back to Excel. Let's try one more way. So I'm running out of time. Okay, let's click on Deploy Model. Click on Cloud Service. This time, I'm going to show you to use RASON option, which will automatically translate the Excel model to JSON syntax, okay, and post it to server, and allows us to work, share the results, and do a lot more. So let's give today's date 6/8/22. Click on Save. Remember, the front-end portal rason.com will open up, shows us a copy of model that is already been posted to the server, okay? In a few seconds, we get the whole model here. Come on, it's still loading. So what is happening is we are offering a cloud service that can serve the purpose of saving, maintaining, and then running analytic models in the cloud, okay? Now, the client that can talk to this backend server could be a web browser, it can be Excel for the web, Power BI dashboard, mobile application, or rason.com. So again, you can see model is automatically translated for you in JSON syntax. Here is the model, okay? You can see everything is automatically translated. And now I can again go ahead and click on optimize, make optimization request to RASON server. It will solve the model and get the results back here for me. Okay, here are the results. So now that the model is sitting on RASON server, it's really easy to share the results with other people. For example, what if you wanted to create a web application? Okay, so let's look into that, how to create web applications. So let's go to deploy model group. Under quick test, you can see a web page, okay? So this is going to convert your optimization model from Excel to RASON modeling language, which is JSON syntax, and allows you to run the model outside Excel in your web application, but the model is actually being run on RASON server, okay? So let's click on web page. So it automatically creates this HTML page. It is actually sitting on local machine. I don't want to do that. Okay. No, okay, sorry about that. Let's go back. Okay, so you can see that in, oh, where did it go? Let me try that again. Sorry about that. I shouldn't have clicked. Deploy model, quick test. It is sitting on my local machine, but let's click on web page. There it is. So let's walk through this HTML web page that's available to us. This part is the model section. Now we have this endpoints that you can communicate with the RASON server to run the optimization and get the results. So let's click on solve or quick solve. There's no data file, so you can just click on quick solve. It will connect with RASON server, and you can see immediately the results are available here for you, okay? On the top, we have my authorization token. You can see that the RASON server URL is reused. And the template for this is actually, for this web application, it's actually available. You can make changes, and this could be the basis for your own application. If you want to learn more, it's really easy. Right click, go to view page source. And here you can see we have HTML for edit fields and button. And if you scroll down, you can see that the part we have the model. We're using JSON syntax. And then here we're using our authorization token. This is the certificate. And then further down, we have everything is commented out to guide you with comments, how to work with server, how to get the optimization request, how to work with optimized endpoint, and much more. Simulate and then delete the extra result. Okay, this is all available to you with just a point and click. Okay, just a few more minutes. Let's quickly look into Power BI and then we can go to questions. Okay. So with Power BI, you can easily create custom visuals. Again, the model, remember we talked about now working beyond Excel and RASON. And one example was web application. I created a web application that works with RASON starting from Excel. Now I want to show you how to work with Power BI, okay? So let's click on deploy model. Power BI, you have the option to use manage model or embed model option. Let's give it a name. So it's 6822. Click on save. Two command prompt windows appear. There are some initial steps you have to follow, and all of them are discussed in the user guide. So after that, so what is happening is we are creating custom visual from this optimization model, and this custom visual, we will open it up in let me open up my Power BI. So you can either work with the desktop or the cloud-based version of Power BI, and these command prompts are also progressing. As soon as they appear, the custom visual is available. Let's see. Something is happening. Okay, Power BI desktop. Let's open that. So goal is to quickly call a model sitting on RASON server, and then we call it from Power BI, display the results in Power BI without any code, okay? And there's much more you can do when it comes to Power BI. And basically you can use the site data SRC. You can specify parameters in the Excel. There it is. So many I open. Okay, you can specify parameters in Excel model that could change. Then you can actually import the data directly to Power BI and run the optimization model and get the run the optimization model. It actually works with RASON server, gets to solve the problem, gets the result back, and shows the result in Power BI. Okay. Again, I created a Power BI from scratch, so it's actually translating the model into JSON syntax, works with RASON server, and as soon as everything complete, we can show the custom visual to you. Okay, so let's see. Okay, this is the desktop Power BI. There are two ways to import a custom visual. Okay, one is from top you go to File, Import Custom Visual, and there's also another way to do it that I will show. Oh my God, I opened so many of them. I keep clicking on it and like 10 Power BIs are open. So let me close some of them. Close. Sorry about that. If you have any questions, it's actually a really good time. Close. Okay. So we go to File, Import, Power BI. So you can actually do Power BI visual from File. And you can see that my these are disappearing. One of them already disappeared. So now second one, so it's ready. You can go to another way is to go to the visualization section. Let me highlight so you can do actually user guide talks about this option. So you can see those three dots. You can click on that and click on import the visual from a file and say import. Now you look for the visual we created 6822 and you can see a Frontline system icon appears. Okay, as soon as that, okay, successfully imported. Let's click on that. Now it solves the optimization model on RASON server and displays the results for you in Power BI. Okay, and again, there's much more you can do with when it comes to Power BI. This was just the introductory example. Okay, this concludes what I wanted to share with you. It's 8:55, so let's quickly look at our summary slides and then answer any questions that you might have. Okay, let's erase this. So again, if I go back to this slide, we learned how to start from Excel, promote our models, to run on RASON Cloud Service and be available to other people. So now we can have different clients that can access the model, run it on RASON server. That's the most important one, that RASON Cloud Service that can serve the purpose of saving, maintaining, and also running your analytic models in the cloud, okay? Okay, now let's go to our summary slide. You can use Analytic Solver for creating, testing analytic models that you can work with a desktop or cloud-based version. And then RASON is a tool you use for deploying, managing, governing analytic models. You can actually easily create multi-stage flows of rules, predictive and prescriptive steps. Let me go back to RASON and quickly show you that this is the optimization model, right? The transportation of goods. On the right side, you can see there's this button. You see that? Show decision flow editor. Remember I showed you a picture in the beginning, a screenshot of the RASON decision flow editor. So with doing that, it actually creates a flow for you. Do you want to convert the model to a new single stage flow? Let's say yes, convert. Okay, so it automatically converts it for you. So you can see this is one step, okay, it's this optimization model. Now, for example, you can drag and drop a business knowledge model, invoke one of your existing models, for example, a simulation model, okay? You can see all the inputs, all the outputs, and if these two models are kind of related and you want to use the inputs of simulation in the optimization or vice versa, build this beautiful multi-stage decision flows, really easy. You can work with the knowledge requirement, drag and drop here. And another beauty is that it automatically translates this flow for you to JSON syntax. So I can click here on JSON model editor and it creates the flow code for you in JSON syntax. So you are just dragging and dropping icons, but it creates the whole code and allows you to just save time with that. Okay, so let's go back here. And this is why I wanted to show that this is exactly the multi-stage decision flow. You saw how easy it is to build that. And you also can take advantage of automatic scheduling that is available to you. Okay, if you have any questions, you are always welcome to contact me at consulting@solver.com. We have a dedicated customer success team that is there to make sure that our customers are successful using our products. So please reach out via live chat on solver.com. You can call us at this number. To start, if you are new to our products, please go ahead and start your trial at rason.com. And you actually have a limited access to RASON when you install Analytic Solver. Okay, thank you very much. I really enjoyed presenting this webinar. I trust it was helpful. We really appreciate your time. I'm going to stand here for a few minutes to answer some questions. So Maysam has a question about, can we use Solver for nonlinear optimization? Of course, as you can see, if you go to the engines, okay, engines of Analytic Solver, we have GRG nonlinear engine that can solve nonlinear type optimization problem. So nonlinear is just a different structure, and we have engines that are available for any structure of optimization problem. Okay, so just choose nonlinear engine. Sometimes also, if you're not sure what engine to use, you can use the automatically select engine option. And make sure to use guided mode if you are not familiar with the steps. Also, if you want to kind of get rid of the guided mode after some time when you are not changing the model, you can actually click on help operating mode and switch from guided mode to auto help mode, which only bring up dialog when there is a problem, or you can use expert mode, which do not bring anything. Okay, it's just that assumes that you are master of it and you don't need any help from Analytic Solver. Okay, let's see if there are any other questions. Maysam, I hope this answered your question. Any other questions? Anybody wants to speak up? I can unmute you. I think I saw a raised hand. Let me see. Anybody wants that summary slide for converting nonlinear optimization models to linear? Also, let me show you on help. Go to user guide, Analytic Solver user guide, and there's a chapter specifically on building large scale optimization models, and it will talk about how to avoid and linearize if function and non-smooth functions. This is a very good chapter, like mastering stochastic optimization concept. And here it is, best practices for building large scale models. Okay, if you're interested, this is a really, really helpful chapter. Any other questions? Okay, don't forget to download the handout. I'm going to share this optimization tricks for you with you also. Desktop webinar. Okay, Analytic Solver optimization hints. So there are two files for you to download: optimization hints and Analytic Solver plus RASON product brief. Thank you very much, everyone. I appreciate your time. Please feel free to provide us with your valuable feedback. You will receive a survey. And join me next week for an overview of Monte Carlo simulation. We will talk about fitting distribution, and we will also talk about stochastic optimization. You're welcome to join us next week for the simulation webinar. Have a wonderful rest of the day. Again, thank you. I will post this recording, and reach out to us if you have any questions. Bye for now.